Great. Hello, everyone. Thanks for having me today. Today's my speech will be more practical, and I will talk more about the AutoML tools, and it will be a practical overview of AutoML especially for tabular data. My name is Dmitry Balabka, and I am from Intexsys. Let me outline my presentation. Firstly, I will briefly describe who I am, where I'm working, and a bit about my current company, Century Group. Then we will talk about the AutoML and what is this exactly, and what kind of solutions exist for AutoML. And then I will give you a practical example of our winning solution for a human activity recognition challenge, which was based on Google AutoML Tables. And then I will share our conclusions, and we will have Q&A session as well. Okay, my name is Dmitry Balabka. My education is, I have graduated Master Computer Science at Transport and Telecommunication Institute. I have a large background and mostly in software engineering. I have started my career in the Forex and telecommunication industries. I spent there about 5 years as a software engineer in web development. Then I switched to e-commerce business and have started my journey in Intexsys working for the Century Group. I spent about 2 years as a software engineer, then switched for the software architect. And 2 years ago, I made a, let's say, tough decision and complicated decision, but I really enjoy it. I have started my data science career. And right now I'm working in a center by solving different data scientist tasks. And briefly about our company, what we are doing in the Century Group. Our company keeps different brands that are mostly known in the United States. We have developed a single platform for the e-commerce, which help us run about more than 10 online stores. Also, we have 2 product brands. We are competing with such large market players like Amazon, Walmart, and others in some specific product segment. For example, Optics Planet, it is our flagship online store, which is leading in industry and which generates our most of your revenue, and focusing on selling such products for hunting, shooting, outdoors enthusiasts, police, and etc. Also, we have another one store like CompSaver, which is focusing on goods that are helpful for interested for traveling, who also like active and healthy leisure and close to the nature. Pretty similar like me. And our store is generating about the annual revenue of $500 million. Our stores is visiting about 4 and 500 million users monthly, who are generating about more than 100,000 of orders. And we're attracting them by sending them emails, about 1 million emails daily. It's actually including also transactional emails, and our stores providing a large variety of products, about 500,000 products in 1 million variety. And by our stores generating a lot of different type of data, and it leads to different interesting ML tasks. Like one of common task for the e-commerce is recommendation systems and customer personalization. We're using collaborative filtering in some cases. Also, we have some algorithms based on product and user similarities, which is based on embeddings due to working with different textual data, we have different NLP tasks. For example, text generation, which is useful in some cases for product description generation. Text classification might be useful in our case for customer services, and sentiment analysis, which is applicable for reviews analysis and classifying them by negative or positive. And for example, name and entity recognition can be useful also for customer services. Another one big segment of the task is A/B testing. All our changes, most of them, let's say, which we are deploying on production, are going through the process of random control experiments. We're using third-party tools like Google Optimize. Also, we have built some tools in-house which help us to minimize the time which we're spending on A/B testing, also improving the sensitivity of them. Another one, like a big and important task for e-commerce, usually is fraud detection. We have some POC in this field as well. Time series analysis, which is important, and in particular for price forecasting, demand prediction, and in some technical monitoring of our system by using anomaly detection as well. And in some cases, it's important to look at the cost with what we are actually spending on our tools. And AutoML is something which might reduce this cost. And let's take a look at what is AutoML and how it actually works. So Wikipedia says that AutoML is automated machine learning, which actually can automate some data scientist daily tasks by automate the complete pipeline of taking the raw data set and generate the model, and then give you ability to deploy this machine learning model. Later, we will see that actually not all AutoML tools give you ability to automate the complete pipeline, but automate it only partially. I will give you an example. So the main advantages, as I already said, that mostly it is the reducing the costs by improving efficiency of our data scientists, because we are rid of some repeating tasks by replacing them with the frameworks or the libraries which actually can automate them. Also, it gives the big advantage of minimizing the errors which can be done by the machine learning engineers or data scientists. And it's obvious because we are minimizing the manual work. And another one important thing about the AutoML is that it democratizing the machine learning and give ability to everyone to use these shine features of machine learning to be applied for your business, for the small business as well. And before dig into details about the AutoML, let's review the typical machine learning pipeline. So initially, we are getting the data, and we are getting the data. In our case, it's drawing multiple different sources like Google BigQuery, MySQL, SQL Server, and others. Then we are processing the data using the basic tools which are providing the Python. In our case, it is Python language and Python-based tools. And then we're generating the features. So the features engineering is in this pipeline might be very costly. Unfortunately, not all the machine learning tools are automating this step of this pipeline, and we will take a look on this. And in an example, I will show that it is not the case for the most of the tools. And then after the featuring has been engineered, we're taking this generated feature, put into some, let's say, library, that providing us the community and training the model. There are multiple additional steps like evaluation model, parameter tuning, and there is some steps of explainability of your model that not always possible. And last but not least, it is deployment, which actually in some cases might be very costly. And then you are monitoring your model to be sure that everything works fine. And the AutoML frameworks usually automate only the part of this pipeline, not the whole pipeline. Still, there are some cases when some services, AutoML services, provide the ability to automate even deployment, or at least minimize the effort to deploy this model on production. And the idea behind the AutoML frameworks, it is not a magic, so it's don't do any kind of magic. It's actually the some, let's say, thin or not the layer above the all existing libraries, and it actually they give the ability to not to write the code like in plain using these libraries, but minimize the amount of this code to the few lines of code. And of course, we have a glue behind these two layers, like using Python, or there might be in different other languages like Julia, R, or even Java or Scala. And after this have been built, our ultimate pipeline changes, but not a lot. Actually, we have some input data, raw data. The AutoML pipeline prepare the data. In some cases, it is not automated, but it might be. Then it build the features and generate the model. And most expensive thing is to select the model. So it try to find some best solution for your concrete machine learning tasks. It search through the list of different algorithms. And then another one important thing is to optimize the hyperparameters, which is it also might be very time consuming, and all this experimentation might take a lot of time. And of course, there might be some errors included, which can be made by human. Then it evaluates the model and even give you explanation why your model works, and shows for example, what kind of input features are working well for your model or not. And then you are getting your resulting model, which can be actually deployed in any kind of cloud or your private cloud, or even using on your local machine. Let's review some existing AutoML solutions. Briefly, I divide this solution into two groups. One is open source frameworks, which actually shines and give you ability to use it freely. And another one is cloud platforms, which usually are paid, but in some cases more complete. Open source frameworks might support different features, and here is some variety of existing AutoML frameworks which I took. From my point of view, they are mostly popular and still in use. For example, scikit-learn is most popular from them. Unfortunately, it supports only tabular data as an input, and it's based mostly on classic machine learning, unfortunately, and do not provide any kind of automation for the image and text processing, as well as deep learning. And another one parameter is XGBoost. Let's say this one is most popular framework, and why I have put it here, because, for example, most of the top solution on the Kaggle platform is the XGBoost, and these AutoML frameworks in most cases help you to train this model, and it actually can be used for your challenge solution. Okay, another one thing is the framework is AutoKeras. It's mostly built on top of neural networks, on top of Keras framework. As you may notice, it's provided to work with the tabular data and the image and text processing as well, because it supports deep learning, and it search through the space of the different architecture of the neural networks to find the most precise and most performant neural network. And PyTorch is something similar but less popular. The difference is that AutoKeras has been built by the Keras community, and that's why it attract a lot of users. In AutoPyTorch, from my point of view, is less popular based on the stars on the GitHub, just because it's built by the different community, which names AutoML.org. But still, it's worth to take a look on this and try it. Another one group of the solutions is AutoGluon and H2 AutoML. They differs, but they different in implementations, but they very common in the provided features. AutoGluon is most complete and give ability to work with the different types of data, train some neural networks, and even provide the solution for the learning the classical machine learning, as well as our powerful XGBoost. And important thing that this framework is provided by the Amazon. So it's behind this framework, there's a big company, and from my point of view, it's really worth to start to use it. But unfortunately, I didn't found that it's very popular right now. Still, in my opinion, it's kind of solution for the a lot of different tasks. H2O AutoML is mostly a platform, but it's provide the API for the different languages like R and Python, so you can use them to train the model using this platform, which is actually written in Java. Okay, let's switch to the cloud AutoML solutions. And in this case, I'm not going to compare them. The reason is that they are mostly all complete. They are working with the different types of input data. They are solving different ML tasks, and they actually provide even ability to deploy your model. And of course, it's tied with the exact cloud where they actually provide these services. And based on the Kaggle's survey, the most popular from them is Google Cloud AutoML. Still, it's question, do we want to actually rely on the survey or not? Because Kaggle is the platform which is acquired by the Google some time ago. So I'm not sure, is it biased or not? Still, today I will present to you some practical example of our winning solution for human activity recognition challenge, and it will be based on Google AutoML Tables. The reason about why we have chosen AutoML Tables is mostly based on our experience, because we had the experience with the Google Cloud and it was great. Another one thing that AutoML Google Tables have won a couple of challenges on the Kaggle, and it was like evidence to we're going in the right direction. And probably another one question might be why I'm going to present the human activity recognition and how it tied with the commerce. The answer is simple. human activity recognition is a topic which is related to the master thesis, and I am continuing research in this direction. Our team was small, yeah. I was participating with my colleague Denis Shklearenko, who is working in the center as a machine learning engineer. Thanks to him for his input, and actually our winning solution was based on our a teamwork effort, and that's why I'm thinking that teamwork is what exactly have give us ability to win this competition. Okay, yeah, briefly about this challenge. Sussex-Huawei Locomotion challenge happens yearly, and this year challenge goal was to recognize 8 classes of user activities in supervised fashion. Organizers provide to us tabular data, which actually can be represented as a large table of the data. And taking this into account, we decided to employ automated machine learning approach to reduce the cost of creating the model, firstly. And another one thing that we can, the time that we actually gain, we have invested into feature engineering, which was very time consuming in this case. I'm sorry, for some reason it's switching the slides. And yeah, as I said, AutoML tables and automated machine learning gives ability to fully automate the process of preparing the data, train the model, evaluate the model, and it's already have some predefined metrics which we actually can use. And the one important thing that it already includes the hyperparameter optimization, which in some cases might be very time consuming. And also its AutoML tables trains different type of algorithms, which in our case wasn't possible to do because we have only 1 month during what we have to provide the solution. And the main disadvantage of the AutoML tables is that it should provide the aggregate data as an input. So each row should be tied with the exact label. And later I will show you what exact problem it actually appear. Briefly about the dataset. Dataset consists of the different types of data that has been collected from the user phones. GPS location, information about the GPS satellites, as well as Wi-Fi access point information, and GSM cell tower scans. All this data has been collected using user smartphones. And here's the list of the classes that we should actually predict. So person might be still, so it's staying, or it might walking or run, or I'm so sorry, for some reason something is switching my slides. I can't figure out what exactly. Sorry. And or the person might use the different transports like bike, car, bus, train, or subway. And before starting to drop this data into the machine learning model, we try to visualize it. And we figure out that actually there are some patterns in the data, in the behavior of the user. Firstly, we can see that data is located in the United Kingdom. Most of the activity is centered in the London and another one part in the Brighton. And in test dataset, we saw this pretty similar patterns, except that we don't have the labels. Yeah, and it is exactly what we should recognize. So we should mark all these roads as what exact activity using is doing. By exploring maps deeper, we found that activities are tied with exact location types. For example, bus, train, and subway classes have their own roads and railways. So this gives us an idea to get the information about the exact location and calculate the proximities to these roads. And first step was to collect the data, and another one thing that we found that some types of activities like sport activities was close to some recreation places like forests or forests or some area where person can take a leisure. And we started to think to collect this data as well, calculate these proximities to these places as well. So the thing is that auto machine learning unfortunately can't give us ability to calculate these domain-specific features. Also, it does not give ability to gathering the additional data. And unfortunately, some pre-processing also can be done with in automating fashion. So all these steps should be done before they're putting the data into AutoML service. So we started to get the additional data. One of them was bus roads. We just get the information from the public available data of the Brighton buses. Another one thing, data set was railways data set. We just put the OpenStreetMap and map it all the railways where we actually can person can use this railway. Yeah. Another one data set was recreation places data set, and we just mark all these parks, woods, and gardens to get their locations. And another one step was to pre-process the data. As I said, there was some caveat, and in this particular case, we found that the measurements we had more than one measurement per label, so we have to aggregate this data. And unfortunately, it has been done manually before we are putting the data into AutoML tables. As I said, that each row should be, as I said, each row should be represented as a single label. And in this case, we had the more than one measurement. And I will show it later how we actually deal with this. In the result, we have generated about 975 features. 975 features. It is a lot. And briefly, we can summarize them as aggregate features, which aggregated radar data into 1 Hertz, and it solves the problem with the multiple measurements per the row, change features, window features, timesheet features, and the last group is the measurement features availability flag, which represent the fact that do we have the measurement or not. Pretty simple. And the question is that, can we actually automate the thing? And answer is probably, because there are some tools, for example, feature tools, which actually focuses on the exact task to automate the feature engineering, but it does not tie it with the exact domain of our data. Another one tool is this Fresh, which in some cases might be useful when you are working with the time series, but in our case, we didn't find it useful, and we choose the road with the manual feature engineering. When all the features has been collected, our AutoML pipeline for the AutoML tables looks the following. So we took the raw data, pre-process the data with the Python script, then generate the Parquet file, which contained all the input data. Then we put it into Google Storage and the Google BigQuery, just because the AutoML requires it, and train the model, use the AutoML Google tables. After that, as a result, we get the model, and we can actually export this as a Google container or the Docker container, and use it on our any kind of cloud, or our private cloud, or on our local machine. Let's actually take a look, brief demo about how the AutoML works, to give you a thought about how simple is working with AutoML tables. I am switching. Let me give. Yeah, here is. So it is the exact model what we have trained. The first step, you are just importing the data, choosing the exact BigQuery project ID, dataset ID. Then you are using some particular table where all your data is living, and then you are just to train the model. So pretty simple. It automatically recognizes the type of the input feature. For example, it might be numeric, categorical, or text. In case of text, it's recognize the text and generates make the feature engineering for the text particular. Because, for example, if you're inputting the raw text, you have to represent it as a vector. Otherwise, it will not work. But AutoML tables make this automatically, which is pretty useful. Then you are inputting the label, your exact column where the label lives, and you're just pressing the train the model. And after that, Google AutoML takes about a few hours based on your input settings. You might choose how long you would like to train the model. The longer training will lead to better result, but unfortunately it will lead to higher costs. So you have to take it into account. Then you are getting the model, and you can here is the represent some brief overview of the model quality, and the evaluation information you can see here. So you see the quality of the model, some particular metrics. Also, you will be able to get some additional insights about the model quality, and some more useful information. You will get the following confusion metrics, which will give you ability to debug your model and see what exact class actually doesn't work for prediction. In our case, there was some problematic class as a running, and for some reason, model have confused this class with their other classes, and then you can actually hypothesize what exact problem is tied with this particular confusion in the model. And in some cases, it might be useful to take a look on the feature importance, and it might give you inside what exact feature works for your model and what exact feature doesn't. And does your input new, if you're inputting new parameter, you might actually see, does it work? Does it give it actually any kind of input for the prediction quality or not? And after you are satisfying of the quality, you can make some prediction, using the batch processing, or deploy this model online, or even export this model, as I said, into container and use it on your own cloud. Okay, back to presentation. In our case, training have took about 3 hours, so we spend the 3 hours cost of the Google Cloud services. According to the Google Cloud documentation, it uses 92 machines power to train the model. It's a lot, actually. And in this training, we used all these features that we have generated. And it is worth to mention that, as I said, AutoML tables use the different kind of algorithms. And in our particular case, AutoML table have switched to the ADANET architecture. There are some other options like gradient boosting decision trees, or some more simple neural networks. But in our particular case, the result was based on the ADANET architecture. On this particular animation, you can see that ADANET is algorithm which actually give you ability to find some precise architecture of the model of the neural network, which give you a higher quality with some theoretical guarantees. And model size is about 3 and 5 gigabytes, which actually a lot. And if you're thinking about deploying this model, it might take not but a lot of RAM of the server. And if you would like to scale this server, it might lead to some problems, but it depends on how much you can actually spend money on these servers. And our conclusion is following. So AutoML helps a lot to train the model. It automates a lot of parts of the pipeline, which actually very time consuming. But unfortunately, domain-specific features can be generated automatically, and in some cases, you have to still have some, firstly, background of the data science and put some effort to generate these features as well. So in some easiest case scenarios, AutoML, it might be very great solution, but in some cases you have to think, will worth to use it or not? But it depends. It's worth to try it and then see, is it work or not for you? Also, it is problematic for us was to compare the different experiments, because AutoML tables switching between the algorithms without noticing you. And it's hardly to say, was it actually the results was tied with the particular features that you have inputted in particular experiment, or was it related to the switch to the new algorithm? So you don't have control in some particular cases of the how it trains the model and what kind of model it trains. So if you are trying to get some precise explanation of your model, and if you would like to be sure that it works and works correctly, then AutoML might be not ideal solution in your case. But if you would like to have quick solution and very cost-efficient solution with the less expertise in the data science, AutoML might help you. All this conclusion actually presented and published in scientific papers that you can find in the internet. And That's it from my side, and I'm glad to answer your questions. All the presented materials is available under the link. And else I would like to mention, sorry about this again, that we are looking for the data scientists in our team, and please contact me privately or ask any questions. Thank you very much.
Can you hear me?
Yes.
Yeah. Thank you for presentation. Here is one question from Dmitrys about slides. Will slides be available to download?
Yeah, for sure.
So how do we make it? Will you send me a link and I publish it somewhere, or how?
I will send you a link, but I will attach the link in the repository here with the code as well.
Okay, and I can drop link in announcement. In announcement, link the title of your talk to the link. So okay, I forgot to drop in a link to feedback form where people can leave feedback. Please. Okay, so yeah, please give us feedback about Dmitry's talk, and if there are any questions, please ask them now or be quiet for life, or how was it? How they say at the wedding. Questions. I will check. Probably somebody dropped something in Q&A.
It seems like the first presenter answered all the questions that we have.
Yeah, it can be. Okay, let's wait a bit. So yeah, meanwhile, while we are waiting, okay, Dmitry is asking. When would you not use AutoML?
Great question. For sure, there are some ML tasks that unfortunately isn't automated with the AutoML or covered with the AutoML. In my experience, there are some cases, for example, that recommendation systems, it's really complicated to find this already automated solution. Some of them are existing in Google Cloud, so they are providing not a kind of AutoML solution, but they are providing the service. And if your business is based on, let's say, is very tight or based on this solution, then probably AutoML is not the case to use it. And for example, if we are talking about them, Spotify, for example, their recommendations is something which is driven, which drives the business. And okay, it's very, let's say, not so precise example, but still. And in this case, I would not start to using AutoML. I will try to start to think about some custom-made solution.
Sorry, I missed the beginning of your presentation. I had to do some stuff. Maybe you already shared about it, but one fact what I didn't share in beginning about you is that you switched to data science from pure software engineering, and you told me that it was complicated and tough decision. Can you share a bit more about it? How was it, or your suggestions if somebody else want to do that? What you suggest to do and not to do?
Yeah, definitely. So as I said before, I was pure software engineer, and actually my journey started in the university, in an institution. I was very passionate about the machine learning initially. I started to read a lot about the machine learning. Firstly, you have to create some information, let's say, put the information around you, put the news. So you have to switch from the pure software engineering news to the data science or machine learning news, start to lead them. And then you are starting to think about what is happening right now in machine learning and so on. And I found that there is a trend. So there is a trend of some kind of particular solutions, which mostly can be actually developed by the pure software engineers. So I had in mind some idea that actually software engineer without the possibility to solve the machine learning tasks in the future might be not so useful, let's say not so useful in some cases. And I start thinking that I should switch it to the machine learning, or at least be able to solve these kind of tasks. And my first step was to write the master thesis in computer science, which would be related to the deep learning. So I took the topic of the deep related to the deep learning, and in my particular case was human activity recognition. And it was actually the point when I have started to switching to the machine learning. It probably worth to mention that courses and, let's say, Coursera or something, it is not exactly what is pretty useful in data science. Yeah, they are practical, but there is something like research, which unfortunately don't what isn't able to get through the courses. And the way how you should research, so the way how you get the data through the research papers, it is the process which you are learning through the writing some research. And in some particular case, master thesis, it is the way where you are learning how to write a research and how to choose the correct metrics, and you are getting the idea what exact metrics are useful or not. And so in my particular case, master thesis was the point where I have actually get all the required knowledge and how to work with the data, how to do the research, and it gave me ability to switch from the data science and to the from the software engineering pure to the data science. So currently, I'm not exact the machine learning engineer, but I am combining the expertise of the machine learning engineer as well, of course, because I have the background, and the data scientist by researching, reading the papers, finding the solution, and applying to the business to solve the business problems and to get the value of these solutions.
Thank you for answer. Here is one more from Benjamin Machine. Interesting. Benjamin, is your real surname or it's a machine learning surname? So question is, isn't compute power time also a concern?
Yeah, good question. So I suppose this question is in the context of the AutoML. For example, if we're using the AutoML, some things that we should take into account, it is the how long we actually would like to spend on searching for the exact model. It wasn't clearly mentioned in the presentation, but all the AutoML frameworks, they spend a lot of time and actually the compute power to find exact model, and they're searching through the really large space of the model, and it might be very costly in this case. And yeah, it is actually the concern. So if we're looking for the a simple model, small model for the not a lot of amount of data, so AutoML probably will be great. So if we're trying to solve something more complicated, it might lead to the problem that we're spending a lot of compute resources to searching through this big space of the models, and it might be costly and time consuming as well.
Okay, one more question here from Padmaraj. AutoML replace data. I assume the question is, do AutoML replace data scientists or improve the data scientist life in future?
Yeah, great question. So it's very popular question from my experience. So firstly, I'm more than sure that replacement of the data sciences will not be possible with the AutoML frameworks. Firstly, but we see the switch in the statistics that based, by the way, on the Kaggle survey, that currently we have a much more persons in the data science who don't have actually PhD and even master degree. So they are basically bachelors who are starting with the machine learning and currently solving some problems with the business. The reason is that, from my point of view, the tools what are currently existing on the market, they are going to simplify the process and the pipeline, and with these tools in the future, from my point of view, there will be possibility to actually simplify this process to this so much to make this possible to actually to make these solutions with the pure software engineering background. Still, there should be some background and knowledge about the metrics, at least. I'm sorry, I don't see the question because there was. Could you please switch to the question? And so you anyway should have the background. So comparing even with the SQL databases, let's say, yeah, this example, comparing with the backend development, front-end developer. Okay, you might be a full stack, yeah, but you have to still have some more deeper expertise in some particular field. So in this case, if you are specializing on the machine learning, you anyways should have some expertise in machine learning. Even if you are pure software engineer, you have to be aware about the some background metrics, different kind of architecture of the machine learning, and different kind of algorithms that you actually should apply for the particular tasks. Even AutoML in current state does not solve it completely. And another one part of question about the improve the data sciences life, yes, for sure. So I hope that we will read of a lot of routine tasks that we're doing currently on the daily basis, and we will focus on the exact solution and we will focus on the exact problem solving for the business.
Okay, let's switch to the Valdis question, and let's take it as the last one. just because of time limits.
Yeah.
So question is, what are the possibilities of using only parts of AutoML? For example, use only data preparation part of AutoML.
If we are talking about the cloud services, I'm not sure it is possible because it is like a black box where you are inputting the data and getting the model in most cases. If we are talking about the frameworks, for sure you can use some part of implementations for the data preparation. And for example, AutoGluon provides you ability to prepare the data to build some features. And as I also mentioned, there is some particular frameworks which is focusing on the data preparation and the feature engineering. You can take them to solve your particular tasks. And once again, yes. So if we are talking about the frameworks, then and they are open source, then you can put the part of the classes or implementation for your needs. If we're talking about the cloud solution, unfortunately, it is black box and it is not possible.
Okay, thank you, Dmitry.